In our work so far with probability statements, you may have seen that we use this capital X notation instead of what we might normally associate to variables in math as lowercase, right? So there is a difference. When we use the uppercase X, it indicates a random variable. And so the distinction here between a normal variable and a random variable is subtle. Okay, the idea with a random variable is that we do not know its exact value at the beginning. Okay, so just like in a random experiment, we don't know the outcome right away. We don't know the value of the random variable exactly. Okay, but what we can do is say it could be this, or in the continuous case, it could be in this range, right? Um, so uh, so that's kind of where the idea of a random variable comes into play. We use the lowercase x to indicate a specific outcome. So the outcome of, a 1 on a roll of a fair number die or something like that. Okay. And so on a fair number die, x could be 1, 2, 3, 4, 5, 6 if it's a six-sided die. Okay. If we have a fair coin flip, it could be x could be heads or x could be tails. Little x, that is. Okay. Um, and so here, those outcomes are known, unlike in the random variable case, x is unknown. All right, so looking at this next example, a couple wants to have two children and are hoping for at least one girl. And so we want to create a probability distribution for the random experiment for the number of girls out of two children and determine that, blah, blah, blah. Okay, so what we need to do is define a random variable. Okay, so G is going to represent our random variable. You could use X. I'm just changing the letter. Ooh. But G is going to be our random variable that in general represents the number of girls out of two. Okay, so we could have 0 girls. Okay, I'm talking about the probability distribution. I better write it down. We could have 0 girls. We could have 1. We could have 2. Okay, and assuming that we have a fair or an equal chance of a boy and a girl, which is usually the case. There's out of 4 different permutations. So there would be boy, 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 girl, 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 and then girl, boy. Okay. So those are the different options we could get. But we'd have a 50% chance of having 1 girl, 25% chance of having 0 or 2 girls. Okay, so there's our probability model. Okay. And G here is just counting, or is representing the number of girls we could have out of 2. And then lastly, it says, P of G being at least 1. We could represent the notation as that, bigger than or equal to 1. And here, this, we could also represent it as P of G equals 1 plus P of G equals 2. Because they are disjoint, you can't have 1 girl and 2 girls at the same time. And if we use our probability distribution, we get 0.75. Okay? The whole purpose of defining these random variables is so that we can have more properties available to us. And when we're talking about a variable, it's always nice to know kind of the center and spread, right? And that's where, with a random variable defined, we can go on and calculate its mean and standard deviation, okay? And here, since we're in the context where we're talking about the entire sample space, or really the entire population, the mean and standard deviation we calculate are actually parameters. Okay, so they correspond for the entire population. Okay, and the mean we're going to represent by this Greek letter mu, like a cat goes mew mew. Okay, it looks like a U with a tail on one side. And then the other one that looks like an O with a tail on top is called sigma, a lowercase sigma. Okay, so we're going to calculate mean and standard deviation. Okay, now I've included all these formulas. What do you need to know and what the hell is the symbol on the right? Well, okay. The big thing that you need to know are the mean and standard deviation for the discrete case. The continuous case requires calculus, okay? So um, the 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 symbol that you see over here is an integral, which you learn about in calculus later on. So we're not going to worry about calculating mean and standard deviation for a continuous random variable. But let's kind of unpack the notation here. It says for the mean, um, we have to do this sigma, that's a capital sigma, of xi times pi. Okay, so this is really just saying to calculate your mean, which is the same as the expected value, they're synonyms. To calculate the mean, you take observation 1, if I was 1, and multiply times probability of 1. Take an outcome, multiply by its corresponding probability. And then plus, add that to, that's what sigma means, add the next one. So x2 p2 plus x3 p3 plus so on and so forth up to your last entry times its corresponding probability. Okay, that's all it means. Okay, and then once you know mu, then you can move on and find standard deviation via this similar formula. To calculate sigma, you have to take, okay, xi, and I begins at 1, minus the mean, square that. So take the difference between the observation and the mean squared times its corresponding probability, plus observation minus mean squared times its probability, observation minus mean squared times its probability, plus, and then all the way through. Okay, this calculation is a little bit more involved, and you won't need to do a lot of it, but I want you to be aware of it. Okay, so then for our probability model that we saw above, to compute the probability, or to compute its mean and standard deviation, right, I would take the observation, so 0 was the first observation, times its corresponding probability. Okay, so 0 girls occurs with 25% probability. Add that to 1 girl times its corresponding probability. And then finally, 2 girls times its corresponding probability. Okay, and I can add that up. And you can do the math, and you would get 1 girl. So what this means is, on average, for this random variable that is number of girls out of 2 children, I would expect one of them to be a girl, which makes sense, right? If each thing is 50%, if a boy and a girl are both 50%. All right, for the standard deviation, okay, this one, a little bit more work. I have to do the observation minus the mean squared times its probability, 0.25, plus observation minus mean squared times its probability, plus observation minus mean squared times its probability. Okay, and so now I can do the math on this, and I get 0.5. Okay, and so that just tells us, like, okay, I expect 1, and then there could be, a half of a kid in either direction, and then you kind of raise your eyebrow. But that's just kind of the units that we have. Okay. So I wanted you to be aware of a random variable and how to calculate its mean and standard deviation, because we'll see an example or two in our activities.